Hey guys, this is 7-1 homework, and I think I said make sure, we're going to take a quick quiz on this stuff, so make sure that you know how to do it. Okay, so I'm going to go back and forth from my notes. These were the notes we did from class, and we're going to use them on the homework. Okay, so a particular college, 78% of all the students are receiving some kind of aid. So that word all is really important. Right? That is our parameter, right? Because it's talking about the whole population, all. And so what do I mean? Like, where did that come from? Okay, well, again, from our notes, a parameter is some kind of a number. So that's that 0.78 is some kind of a number describing our whole population, all. So that was a proportion though. So that's why I picked the P. Now, how do I approximate the parameter? I approximate the parameter by taking a statistic, which is information I collect from the sample. So again, the statistic is the number that describes the sample. So let's take a look here. Then it states the school's newspaper selected a random sample, okay, of 100 students, all right, and in that sample, 72. So 72 out of the 100 said they're receiving some sort of aid. So that is a sample data, which means it's called a statistic. So I'm looking for this. 78 is the parameter. 0.72 is the statistic. That is the correct answer, choice C. All right. All right, let's, based on our notes. 27, a statistic is an unbiased estimator of a parameter when. Okay, so that came up in the notes. A statistic is an unbiased estimator if the mean of the sampling distribution is equal to the parameter. So let's think about this. The mean of the sampling distribution is equal to the parameter. So we showed this happening here, right? The mean of the sampling distribution, 75 was the mean of the sampling distribution, and it was the same as the mean of the population. They both were 75, but for different reasons. This is the mean of the population distribution, 75. This is the mean of the sampling distribution. So it's unbiased when that happens. Okay, so let's take a look. Which one makes a best fit here? A statistic is an unbiased estimator of the parameter when the statistic is calculated from a random sample. So just because it's random, that's probably not going to be good enough. In a single sample, no, we didn't, right? We took many. In fact, we took all the possible samples of sample size of 2 for that to happen. In many samples, okay, so I like that. The value of the statistics are very close. Okay, that doesn't sound exactly, so let's keep going here. In many samples, like it, the value of the statistics are centered at the value of the parameter. Okay, so that's exactly what happened. So I'm going to pick that one as my answer. I do want to eliminate E though. In many samples, the distribution of the statistic has the shape approximately normal. Okay, so no, that's not what we're looking at here. Okay. Next question, number 28. In a residential neighborhood, the distribution of health values is unimodal and skewed right. Okay, so that's with a median of 200 and an IQR of So I'm going to give you some data, which probably will help you kind of envision this. I'm going to run out of room. Okay, I'm not doing too well here. Okay, let's try again. 0, 50, 100, 150, 200, 250, 300, 350, 400. So what is some data that could kind of describe what they're talking about here? So essentially what they're saying is what if the median was 200? So that's, and it's unimodal. So the median would be, let's say, here's my data here, right? Right, maybe there's data on both sides here. It's 200. And an IQR of 100, that means the inner half of the data is 100. So the width of this is 100. So if I overlaid a box plot, right, and my median is at 200, and then, here's the whisker. Maybe the cheapest house in town is 20 grand. And maybe the most expensive, it might go crazy here, right? It could go way up here to $1 million or more, right? In this residential neighborhood. Let's say the fanciest house in that neighborhood is $750 in this one residential neighborhood. So it's skewed right, meaning maybe there's some fancy ones, right? And then there's half the data. So half the data is to the right and half the data is to left of the median. Unimodal, meaning it's one peak, so we got that. It's definitely skewed right because there's some more expensive homes that are pulling the mean to the right, which is why it's called skewed right. And it says, for which of the following sample sizes is the sample most likely to be above 250? Okay, so again, this is my population data. Okay, this is my population distribution. And so this could be, 2,000 homes. So if I had a really high number, then my median is probably going to be pretty close to this same median. You see what I'm saying? This is likely going to have a median of pretty much the same thing. Right? Even this is probably going to have a median of pretty much the same thing. So what do I mean is I'm randomly going to pick 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those 10 homes, I'm going to add them all up and find the number in the middle. It looks like I got a number pretty close to 200. Randomly select some homes, 10 of these. And look, there's only a few down here. So what most of the homes out of your 10 homes are going to be right in here. So who's the most likely to be, or which one, to be above 250? And here I've got to select A, okay? And the reason is that the more let's go to my notes. The reason is, when I increase the sample size, the sample distribution variability will decrease. So what that tells me is these are going to be pretty darn close to that same number, 200, with very little variability. So since this varies greatly, the lowest number is the most likely to be that far away. And that is, as far as the mean, far away. Who's most likely to be above $250,000? Our answer is 10 because it's a small sample size. And because 250 is pretty far away from 200. Okay. 29. It says increasing the sample size of an opinion poll will reduce what? So back to our notes, increasing the sample size will increase the increasing the sample size will decrease the variability of the sample distribution. Okay, so let's find the one that matches here. We've got B. It will reduce the variability of the estimate made from the data collected in the poll. Perfect. it's not going to change the variability of the population, right? I'm taking a sample that won't affect the population. It will, D is looking good. The variability of the opinions, right? But this one's more accurate, all right? Non-response has nothing to do with this. And again, bias would not come into play if all I'm doing is increasing sample size. All right, number 30. This is most like the activity we did today. So let's think about this for a minute. A math department has a small school, 5 teachers. So this is similar to what we had. We had 5 students today. So this is our population. Now it says, suppose you selected a random sample of 4 teachers. So what would that look like? Well, it could be these 4 or these 4, right? Or these 4. So let's see. It could be everybody but the first person, everybody but the second person, everybody but the third person, everybody but the fourth person, or everybody but the fifth person. So I know that there's 5 dots. How could I also get my calculator to come up with this number? Well, it's 5 teachers, and I'm choosing 4 of the 5 teachers, and that gives me the number 5. Okay, so I'm eliminating A because it doesn't have 5 dots, right? And what would be, it's got to be D, right? Like these numbers are spread out, but hold on a minute. Let's actually calculate a couple of these. So suppose you select a random sample of 4 teachers and calculate a sample minimum age. Oh, that's different. Which of the following shows a sampling distribution of minimum ages? Okay. So in the first, I picked everybody but the first person. So the minimum age is 34. Meaning I picked these and the youngest person is this person, right? Now I picked everybody but the second person. So the youngest person, the minimum is 23. All right, this is kind of cool. And now I picked everybody but the person who's 37. And so the minimum age is 23. And I picked everybody but the 42-year-old. So the minimum age is still 23. And I picked everybody but the 58-year-old. So the minimum age is still 23. And so if I graph this, I get 4 23s and I get a 34. So my answer is C. Thanks for joining us today, guys. Best of luck. Study for that quiz. Take care.